Here we show three different ways of measuring the thickness of a precision optic. The most accurate technique would use a height gauge, or it might be called a depth gauge, in conjunction with a granite slab workbench. The second most accurate would use a hand micrometer, and here we have a hand micrometer with a 1 to 2 inch range. And the most common and probably quickest and easiest way to get a measurement would be with this caliper here. And I'm going to make three different measurements of the same prism, and I'm going to measure the separation between the two ground surfaces of this prism. If I use the height gauge, I'll first ensure that the ruby tip of the height gauge is in contact with the granite slab, and then I'll zero the height gauge. I'll lift the height gauge and slide the optic to be tested underneath it, and then gently allow the ruby tip to rest on the height gauge. This reads 25.133 millimeters. So that's a fairly accurate measurement. Now if I take the hand micrometer, I have to open up the jaws of the micrometer larger than the width of the optic under test, and then I gently roll the plunger so that it contacts the surface until gentle turns no longer turn it. And here this reads 25.140 millimeters. So a very similar measurement, only off by a couple of micrometers. And here I can take a caliper and perform the same measurement. Caliper, you'd want to use the same way as a height gauge. Make sure the jaws are closed and make sure the caliper is zeroed and that it's in the right units. Open the jaws of the caliper larger than the optic under test. Slide the optic under test so that you get a lot of the meat of the jaws on the part itself, and then gently close the caliper until you get a firm grip on the part. You don't want to force this in any way. And this reads 25.13 millimeters. Slightly lower resolution for this slightly less accurate tool. However, this is the quickest and easiest way to make such a measurement because not everyone can carry around a granite slab in their pocket. When calibrating something like a granite slab, you'd want to use a set of gauge blocks. And here I have a 1 inch gauge block, and we'll actually slide that 1 inch gauge block underneath the height gauge, and you can see that this is extremely well calibrated to 25.400 millimeters. So the 1 inch gauge block reads exactly as it should on this height gauge. And here is an entire set of calibrated gauge blocks that you would use to make comparative measurements to precision optics, ranging from 4 inches. In order to measure the wedge of a precision optic, that is the angular deviation between one surface and the other surface, we can use a simple setup that consists of only a helium neon laser. So this helium neon laser can be used with the optic under test. If you take the optic and you place it in the path of the helium neon laser, you can see that both surfaces return a reflection onto the surface of the laser. The separation of those two reflections is measured at about 8 millimeters, and knowing the physical distance between the plane in which you measured and the precision optic itself, which in this case is about 250 millimeters, we can determine the wedge of this block. Now, if you have an unwedged precision optic, here this is a very well-made plane parallel optical surface. You can see that when it's placed in the laser beam, only one beam is actually returned to the laser. That is, both surfaces reflect a beam back towards the laser, and those two surfaces overlap, because in this measurement configuration, we don't have the resolution to actually see the difference between any small amount of wedge that might exist in this very well-made precision optical parallel.